This video is on the objective calculate the margin of error for a confidence interval for a mean, where the population's standard deviation is known, right? Sigma is known here. And this is number one, right? So this is the first video where I'm going over a question related to this objective in your Newton Alta homework. So again, if you are unfamiliar with this topic, you want to learn more about it, please click on More Instruction and read through the material they have, watch the videos, look at the examples, and hopefully that'll help you out. Alright, so I'm just going to go through this question and do it my way. So here, the weekly salaries of sociologists in the United States are normally distributed and have a known population standard deviation of $425 and an unknown population mean. Right? Again, we're forming confidence intervals for a mean, so whenever you form a confidence interval, that means you're guessing what the population mean is. So you should be an unknown population mean. But we do have a known population standard deviation, a known value of sigma. All right, so from this population, a random sample of 22 sociologists is taken and gives a sample mean of $1,520. So that's the mean for this sample of size 22. So we're asked here to find the margin of error for the confidence interval for the population mean when there's a 98% confidence level. Right, and round your answer to 2 decimal places. Okay. So on some paper I'll describe what's happening. Right. So we have this population of sociologists and their salaries, right? So the population is, let's say it's made up of all sociologists. And I'll have this variable x represent the weekly salaries. Weekly salary. Now it is told to us that the weekly salary of all these, of all sociologists is normally distributed with some mean mu and some standard deviation sigma. Mean mu is unknown, right? And we're going to try to guess what mu is with a confidence interval, and be 98% confident here. I'll be 98% confident that the true value of mu is somewhere between these two values. That's what a confidence interval is. And a standard deviation is known here, and it's $425. All right, then from this population, a sample is taken. And it's a sample of size 22. So n equals 22 sociologists is taken. And their average salary, right, the average of these 22 sociologists, their average weekly salary is $1,520. So X bar, right? So again, imagine you could take all possible samples of size 22, all possible groups of 22 sociologists, and look at their average salaries. So again, this is the average weekly salary of 22 sociologists, of 22, I'll say people, all right, 22 sociologists. Now, because the population we were pulling from was normally distributed, because this is not 30 or greater, but the population was normally distributed. So by the central limit theorem, the distribution of all these sample means, the sample means for samples of size 22, the distribution of those sample means would be normal, with a mean of mu sub x bar and a standard deviation of sigma x bar, where the mu sub x bar is the mean of the population, but we don't know this. We don't know what this is. So we use a point estimate. We use our what's our first guess as to what mu is, and that's our sample mean. We're going to use $1,520, right? Use our as a point estimate. And the standard deviation of these sample means, if you recall, was the standard deviation of the population divided by the square root of the sample sizes. Well, we know these values. This was 425 divided by the square root of 22. And I'll round this to a certain number of decimal places here. Let's give it this. So 425 divided by the square root of 22 is about $90.61 standard deviation for these sample means. Now on the calculator here, I'm going to store this value. I'm going to hit the stow button and store it as x. So now every time I use the letter x, it's just that standard deviation. Okay, and then I'll draw a picture of the distribution of the sample means here for samples of size 22. There's a number line with all possible values of x bars, right? And this distribution is normal, so get a nice symmetrical bell shape. It's not very symmetrical, I apologize, but and then underneath the peak we have our population mean, right? The mu, but we don't know what mu is. So again, we use our sample mean in the middle here, our point estimate when we use 1520. And then from this we try to create a confidence interval, right? I'll find a lower value and an upper value that'll give me a guess as to where mu is, right? Where is this mu? What is the value of mu, the mean weekly salary of the entire population of sociologists? Well, to do that I need a confidence level. I want to know how confident do I want to be. So we were told to do a 98% confidence interval. So we have 98% confidence. Now, if the confidence level is 98%, remember there was this value that shows up in your reading and stuff called alpha, which is called the significance level, which is the percentage left over. Right? If you're taking up 98%, what's left over is 2% or 0.02. Okay, so let's keep that in mind. Now, what we're looking for, right, when we create a 98% confidence interval, is I'm starting from the middle here, and I'm going to go, to some value above, which will be 1520 plus, this margin of error, and then that same value below the middle. Right, so over here this would be 1520 minus the margin of error. And I want to figure out what these values are so that the area under the curve between them is my confidence level. This area is 98%. Okay, so in order to find these values, I need to figure out this margin of error. Right, now the margin of error, in order to find the margin of error, I need to figure out how many standard deviations above the mean is this value, or how many standard deviations below the mean is this value. Well, when I talk about how many standard deviations away from the mean am I, that's a z-score. So I need a z-score. So it's a z-score, and then there's a little subscript on the z-score, and it's going to be half of alpha. You're going to see this showing up. You're going to see this little symbol z. Because remember, if there's 98% between, that means there's 2% left over. And if there's 2% left over, that means there's 1% up here, 1% down here. Now 1% is 0.01. So in order to find this value here, right, what is this upper limit? And figure out how many standard deviations above the mean it is, I need to know the z-score with 1% above it. the z-score with 1% above it, that's this z.01. So you'll see this a lot, z-score with some number below it. This means what's the z-score with this area above it, right, or to the right. And I'm this many standard deviations above the mean. So I need this many, whatever z.01 is, standard deviations. And the standard deviation was this, sigma over the square root of n. And this is how you calculate the margin of error in general when you're creating a confidence interval estimate of the population mean. In general, the margin of error is your z-score with an area of half of alpha above it times the standard deviation, which is that sigma over the square root of n. Right? I'll put this in a box here. This is huge. And I know these values. Now z.01, the z-score with 1% above it is given in my little chart here. See, z.01 has is 2.326 standard deviations. 2.326 standard deviations. So back on my picture, it means that this upper value in my confidence interval is 2.326 standard deviations above the mean. So 2.326 times this 90.61. That's how far above the mean this value is. And then this value is 2.326 standard deviations below the mean. Right, so it's 2.326 times 90.61 below the mean. But all we're asked to find here is the margin of error. Right, so the margin of error for our confidence interval is going to be 2.326. Right, that's the z-score with 1% above it times the sigma. That was the 425 divided by the square root of 22, the 90.61 that I had there. And they're asking us to round our margin of error to 2 decimal places. Well, I'm going to pull up the calculator. Right? And let's enter this stuff. So 2.326 times, well, I don't need to hit x. I can just go the previous answer. That was that. Oops. All right, so let's try that again. 2.326 times the previous answer is above the minus sign here, right? Yeah, so that'll be times the 90.6103 something. So yeah, so the margin of error is 210.759, so 0.76 if I round to 2 decimal places. So this value is 210.76 above. This value is 210.76 below 1520. And the area between them will be my 98% confidence, right? So I'd be 98% confident that the true value of mu is between whatever those two values are, right? But we're not asked to find those two values. We're just asked to type in the margin of error, that z-score times the standard deviation. So it's 210.76, right, if I round to 2 decimal places. And again, if I got it correct, please again, see the formula there for margin of error. When you're estimating a mean, there's going to be a different formula, but pretty similar when you're estimating a proportion. We'll get to that in a later section. But when you're estimating a mean, for trying to estimate mu with some confidence interval, there's your formula for your margin of error. And again, it's all the same stuff. And I don't think there's a second part to this. No, there isn't. So hopefully that helps with that kind of problem, and thank you very much for watching.